Okay, Chapter 5, Lesson 1, Example 7. Rewrite as an expression that does not involve a fraction. So notice this one does not say simplify to a single term. We just need to make sure that our answer is as simplified as possible and does not contain a fraction. Now, we provide a hint. When the denominator is in the form of 1 plus or minus u, you can sometimes multiply the numerator and denominator by the conjugate of the denominator and apply a Pythagorean identity. Okay. So, in the example number 1, notice my denominator is in the form of 1 minus a term. Okay. I could multiply the numerator and the denominator by the conjugate 1 plus sine x, all divided by 1 plus sine x. And what happens is it creates in the denominator one of our Pythagorean identities. So if I go ahead and multiply, I have cosine squared x times 1 plus sine x, all divided by, and 1 minus sine x times the quantity 1 plus sine x. If I distribute, okay, using FOIL and the distributive property, it's a difference of two squares, 1 minus sine squared theta. I'm sorry, 1 minus sine squared x. Okay. Now, 1 minus sine squared x is one of our Pythagorean identities and is equal to cosine squared x. So I now have cosine squared x times the quantity 1 plus sine x, all divided by cosine squared x. Again, using the Pythagorean identity to substitute for my denominator. And then I have a cosine squared x in both the numerator and the denominator. So my final simplified expression that does not contain a fraction is 1 plus sine x. Okay, letter M. We have 4 divided by secant x plus tan x. My denominator has 2 values that's not squared and being added together. So I could simplify this by multiplying the numerator and the denominator by the conjugate. The conjugate of secant x plus tangent x is secant x minus tangent x. Distribute, multiply straight across. 4 times secant x tangent x, we'll have 4 times secant x tangent x. I'm sorry, minus tangent x. When you multiply by the conjugate in the denominator, it creates a difference of 2 squares. Distribute, and it will simplify to secant squared x minus tangent squared x. From here, we will be able to apply a Pythagorean identity. Now, if you recall, tangent squared x plus 1 was equal to secant squared x. Okay, I'm going to subtract tangent squared x from both sides. So I have 1 equals secant squared x minus tangent squared x. So I can replace secant squared x minus tangent squared x with 1. So I have 4 times the quantity secant x minus tangent x, all divided by 1. Okay, so all I'll have left is the numerator, and I can distribute the 4, and this simplifies to 4 secant x minus 4 tangent x. Problems in which we multiply the numerator and the denominator by the conjugate does not come up near as often as the previous set of problems that we've went through, where we needed to put things in terms of sine and cosine. We need to look for greatest common factors. We need to add and subtract fractions using common denominators. Pythagorean identities, those are definitely more common than having to multiply by the conjugate. But if you get to a point and you try the other problems and they don't work out, then you might want to come back and double check to see if the conjugate process would work. Okay, I would like for you to go down to the bottom, and I would like for you to attempt problems 9, 10, 11, and 12. Okay, simplify each expression. Okay, give it your best that you can, and I am going to post the answers. So then I would like for you to check and see if you can get the final answers. Make sure you write down any questions that you have. Good luck.